So just a refresher to kind of think back to before break about the different kinds of angles that we talked about. We've talked about inscribed angles. And we've talked about central angles. So remember that inscribed angles have a vertex on the circle. And central angles have a vertex at the center. Okay? We also know that inscribed angles are half of their intercepted arc. And central angles are equal to their intercepted arc. So if we look at where this question mark is, we can see that the vertex of this angle lies on the circle, which means that this is an inscribed angle. So this angle here is half of its intercepted arc. So to find its intercepted arc, remember, we just have to follow the sides out until we see that this is the arc. And we can see that this here is the diameter. So because this is the diameter, it means that there are 180 degrees in this arc from Q around to S. So if we take 180 divided by 2, we can see that the question mark would be 90 degrees. For number 2, we're looking for the measure of angle CAE. So remember, an angle would have a vertex either on the circle or in the center of the circle. And in this case, A, which is our vertex because it's the middle letter here, is at the center of the circle. So we need to know what this whole arc is right here because central angles are equal to their intercepted arc. So if we can figure out what this arc is, then we also know how many degrees in this angle here. So first off, if we can see that this is a diameter right here, we know that from F to E to C is 180 degrees. But we also know that this arc right here is 80 degrees. So if we can subtract 180 minus 80, we have 100 degrees left. So this arc right here would be 100 degrees, which means that this angle is also 100 degrees. All right, today we're talking about secants and tangents. We have 2 sections left to go before our chapter test, which will be on January 11th, which is a week from tomorrow. We're adding another angle. So we've already talked about inscribed angles. We've talked about central angles. We're going to also be talking about secant angles and about tangent angles. And we're going to have to know the relationship between those angles and their intercepted arcs as well. So first thing we need to do is define what a secant is and what a tangent is. So secant is a line that intersects the circle at 2 points. And so we can see here there's one intersection point here and there's one intersection point here. And a tangent is a line that intersects the circle at only 1 point. So with a secant, you have part of the line inside the circle. With a tangent, you have no part of the line inside the circle. A tangent is completely exterior to the circle. All right, the next theorem that we're talking about is only dealing with the tangent. So if a line is tangent to a circle, so this would be our tangent line, and it's tangent at this point right here. So if a line is tangent to a circle, it is perpendicular to the radius. So the radius, remember, goes from the center to the edge of the circle at the point of contact. So basically all that means is that if you have a tangent and a radius touching each other where the tangent meets the circle, then that creates a right angle, perpendicular lines. So here's your radius. Okay? So in example 1, we have that AC is tangent. So this line right here is tangent to the circle at this point right here. We can also see that from O to C, so here's our tangent, here's our radius. Okay, since this is the radius and this is the tangent and they're meeting at the point of tangency, we know that this is a right angle down here. What we are trying to find out is what's the measure of angle AOC. So AOC would be this angle right here. Remember, this tells you where your vertex is. So if you start at A and go to O and end at C, this is your angle right here. So we also know that perpendicular lines form to meet at a right angle, and we know that all right angles are 90 degrees. And if you look, you can see that in addition to a circle being here, there's also a triangle. So if we know that one angle is 16, one angle is 90, we can easily find the third angle. So if we take 16 plus 90, we get 106. And then if we take 180 minus 106, we get 74 degrees. So this angle up here is 74 degrees. All right, this is the angle that we were talking about. We're gonna add this in with our central angles and with our inscribed angles. So a secant angle has two sides that are both secants. And the vertex of the secant can be either inside the circle or outside the circle, but not usually at the center of the circle. So we already know how to find central angles. What we're talking about is when it's not at the center of the circle. And this will certainly work if your vertex is at the center of the circle, but it won't work if your angle, this formula won't work if you are, I don't know what I'm trying to say. Anyway, each of these dots are in the place where the secant angle is. So if the secants intersect inside the circle, you're going to end up with multiple secant angles. If the two secants intersect outside the circle, you're going to end up with only one. So this is a secant, this is a secant, and these are both secants. So you can see where they intersect. The intersection of these two secants is outside. And this intersection point is inside. All right, so the important part that we're going to get to today, the important part to know here is that this is the formula for when you're finding secant angles when the vertex is inside the circle. So if we look here, we've got the measure of angle APD. So again, there's our vertex. And with this one, there's multiple angles that meet at P. So we have to start at A, go to P, and then end at D. So the angle that we're talking about is this angle right here. Well, because these are two secants and they intersect here, we also know that this is a vertical angle here, and we know that vertical angles are congruent to each other. So APD and CPB are actually the same measure, and these two right here could be used interchangeably just for measurement purposes. So when we're trying to figure out which arcs to use, because it's not always going to be labeled AD and CB, what you're looking for is you're looking for the angle that you're looking for, look for its vertical angle, and then find the intercepted arc of each of those. So the intercepted arc for CPB would be arc CB, and the intercepted arc for APD would be AD. So these are the two angles that you would add together, and basically what you're doing is you're finding the average or the mean of those two arcs. So just for example, let's say that this was 88 degrees here and this was 112 degrees here, and this is not to scale, so don't think poorly of me for this, but this is just for the purpose of giving us an example to see. So all we have to do is just take these two arcs, so 88 and 112, and we're going to add those two together. So 88 plus 112 is 200 degrees, and half of 200 degrees is 100 degrees. So each one of these angles in here, CPB and APD, are both 100 degree angles. Same thing here, we have the drawing, circle O, and we have the two secants. Now, sometimes your secants are not gonna extend past the circle, but if you imagine extending them, you can see that we can easily turn these into secants. You can also see that it doesn't go through the center, so that's another way we know that these are secants. So if we are looking for measure of angle APB, so A is here, P here, B here, we're looking for this angle right here. So in order to find out what that angle is, we need to find its vertical angle and then use the intercepted arcs for each one of those angles. Okay, so we know that AB is 69 degrees. We know that DC is 163 degrees. And so all we have to do is just take half of their sum. So 163 plus 69, and I believe that's 232 degrees. And so half of 232 is 116 degrees. So this angle in here and this angle in here are both 116 degrees. So we'll finish the notes on Friday and get the assignment. And if you have any questions, let me know.